with the portal Casadomo to collaborate. It's I think it's the 6th time, and it's a pleasure to be here with you. This workshop consists on 3 speeches, quite different speeches. I think that the most comfortable thing, as the table is now with 1 speaker, we'll see every speech, and then if you have any kind of question, a couple of questions, to give you, to let you interact, and without enlarging it a lot, we'll have our speakers on the table, and the first speech is about the evaluation of a platform of cognitive stimulation based on tactile devices. We have here Victor Manuel Pelaz, who comes from the Department of R&D, and I from CETIC. Thank you. Well,
Good afternoon. En el que no solo ha participado CETIC, sino que hemos...
Well, we have had the collaboration of the center, the reference center for the study of Alzheimer and other diseases that is in Salamanca. For the ones that don't know CETIC, we are a private entity, a non-profit entity. We are based in Gijón, and we are specialized in technologies of information and communication. We have 2 parts, one more focused to technological services for companies, another one that is the Department of R&D and I, that is the one to which I belong. If anybody knows us, it's because we host the office of the W3D for Spain and Latin America. We are very active in groups of W3D, and we have developed, we have a TAO tool which is used to verify these standards. Well, I'm in the Department of R&D, in which we are focused to innovation projects and investigation projects in these 5 groups or 5 specialities that you can see in the slide. And one of it are the technologies focused on people, in which we work with collectives that have Down syndrome or people with Alzheimer or any kind of mental problem, which is as is the case of this investigation. As I'm sure you know, the Alzheimer, as of today, has not a treatment for which, in order to solve this problem, we have pharmacology therapies and non-pharmacological therapies. We have different solutions, methods, in order to make exercises of cognitive stimulation, tactile exercises on web platforms, television, etc. The main problem of these therapies, is that although they are very used in specialized centers, people have a low motivation, and many times it's difficult for them to use it during a long time. There's a low adherence to this kind of therapies. We have therapies of social interaction, in which we put some people with problems in touch with people with the same problems, and we have shown that this is a very useful activity, because people that have a good social network need more time to develop this kind of diseases, and when they develop this kind of diseases, their quality of life is better. These investigation research projects, is focused on therapies of cognitive stimulation through electronic devices. Now we can see that there are many applications and investigation projects that are commonly used in assistance centers, but no matter they are on a mobile device, on a PC, on a tablet, in the end, all of them have the same problem with the motivation of the users. And of course, the problem of usage on a long term. The motto of our investigation was to develop an investigation in which we had a multi-user multi-part. There could be a multi-part participation. Could even be of many generations, not only for the person that has a problem, but also for his relatives or friends, etc. We wanted to see if we could accomplish it so that the system was easy to use and could ease the motivation of users. We proposed a relatively easy system, which is the one you can see on the slide, on the screen, where if we are talking about cognitive stimulation, we are talking about a game that enabled us to exercise cognitive capability with some devices, an iPad, a PC, a device with Android, that enabled the user to access the game, but where another users, for example relatives or physicians, could participate from a social network or from a web environment. In order to synchronize both parts, we established an intermediate element to synchronize it and to have a multi-user game, and eventually a physician can monitorize everything that's happening in that games to see the evolution of the people and to see which corrective actions could be implemented for that person to improve the state or the situation of that person. So the decision we took was to integrate the concept of social networks and multi-participant systems into a system of cognitive stimulation, a more traditional cognitive stimulation system. We have got involved the patients, the relatives, and the professionals. These games support the individual game. Many people know already these kind of games because they already use it. And the multiplayer option, it can be played remotely between people that are in different places. The collaboration with professionals of CREAM Salamanca, regarding that, we decided that the best possibility for this study could be the memory games, to see card pairs and to establish the rule that you had to establish all the pairs with the cards. And with this hypothesis, or with this idea, we developed a small prototype technological solution using this architecture that enabled us to make tests with users and to verify our original hypothesis. As we commented yesterday, we use a design methodology focused on the user. We would be an iterative process in which we were moving on from an original design made up between engineers, users, and physicians. We developed it and we provided it to the user so that they could put their hands on it, to touch it and to see which things weren't good, which things should be changed, etc. That way we obtained another feedback, we changed the design, and we implemented a new prototype, and eventually we reached a solution with which we were all satisfied. For the user interface, we are trying to apply the rules in which we were saying, for example, that we have to make a simple and consistent interface with high contrast. In the case of elderly people that can have a cognitive problem, that this interface doesn't have many text that are easy to use, etc. Well, on the next slides, we are seeing some screenshots so that you can make an idea of the interface of the game in a tactile device. But if we play from a web platform, the interface would be identical. The user should only access to the application and log in with the account of a social network, or the device can be configured for that user, and he has to be conscious that the device is saying hello and it's customized to this user. They can play alone, or they can play against friends or for relatives which are on a social network or available or online, to dedicate their time on a therapy that can be useful for the patient. On a visual way, you can select against whom you want to play, in which, and here you can see a panel where you can see them hidden cards, and you have to push on them to see them and to make pairs. Now here we are developing the short-term memory. The images or figures that could be used, or even the time that is shown, the time that the cards are shown to the user, can be configured so that we can adapt the difficulty of the game to the degree of deterioration of the final user. Well, you can figure out that the dynamics of the game are to see the cards, and if they fail, the turn would be for the opponent. The objective was to do a validation with users. We were trying to validate our original hypothesis. For that, we have the help of the CREA and the users of the CREA, and we established an evaluation to know if users could use this application correctly, the tactile device, testing the application on a tablet of 7 inches or 10 inches in order to see if the size was important. If they could develop correctly with the game, and which was their user experience. For that, we used two users of Korea with an average age of 79 years old. All of them had a moderate level of cognitive deterioration, and there were some other tests during which the devices were there and the physicians could use them for the different workshops that they do there. The mechanical of the proofs were of the process was very simple. They could play alone or in multiplayer way. They observed the behavior of the users, and the platform was compiling parameters or characteristics about the way the users were interacting with the system. Which were the results of this observation? Well, the usability of the system, or to see if the users could work with the tablet, the answer is yes. They were able to manage the tactile device without any problem, and they were able to follow the mechanics of the game. The developers of the CREA are people that use Wii, another kind of technology. The only problem with tactile devices was about the way that the users were holding it. But generally speaking, the experience was positive. If the multiplayer game motivated them, yeah, the answer is yes. The fact that a partner was beating them or they were losing against another partner, that motivated them, because it's the competition. It's a very strong thing in nature, and they could decide if they wanted to go on playing or not. Because when they moved on to the multiplayer option, because the times between they had to look for a card and the next card, their short-term memory wasn't good enough to remember the cards, and there were players that on an individual mode they could solve the questions, but not in multiplayer version. These kind of solutions would be positive for users with a moderate deterioration level, and it could be useful for them, and that would improve their motivation. But for users that have a moderate deterioration degree, would need a supervision by a physician to accomplish the training activity successfully. Those were the conclusions, and that motivates us for our future works. It's trying to check this with different users, because 12 users is not a very high figure, and because of the comments that we have received, it would be positive to include a new functionality that is that for players that are not face-to-face, it would be great that they could see themselves to establish more visual interaction while they are playing. And well, just to point out that this investigation work was developed within a project that is called Cognigen, which was co-financed with the National Plan of Scientific Research and by the INSERSO. And that's all. Thank you very much for your attention, and if you have any kind of questions, you can ask it.
Muchísimas gracias. La verdad que me ha parecido súper.
Thank you very much, Victor. I think it has been really interesting. I have many questions, but I think that we would let the audience, if you have any kind of question or doubt regarding this speech, there's a microphone back there. If you have any kind of question. Well, what do you think about the medium-term convergence of these developments and their integration within existent social networks? Well, can you hear me? Yeah, the prototype that we developed was integrated in Facebook. In fact, the tests that we made was a person connected to Facebook could directly play with a person that could be another place. But the problem is the access for elderly people or people with some cognitive problem to that social network, because well, they can have that problems. In the system that we have developed, these persons had to create an account, and we can create a test account, but it could be difficult that some person with a cognitive problem can access by himself or herself at network of this kind. Well, the game could have created its own network to simplify the creation of users and to have a much more confident network. But we thought that the added value would be in using a network where we could find their relatives in general basis. Well, as interfaces for these social networks, do you think that they provide enough flexibility for you, or do you think that it would be necessary to develop some more things? Well, when you develop a platform within a social network, it's just a little world in the social network, and you can do it as accessible or usable that you want within the network. The problem is you have around you everything that implies connecting or logging into the social network to introduce to type a keyword. It's not the same creating a game or a platform that all that surrounds the social networks. For example, initiatives that, as we have seen in the previous roundtable, like social networks specifically focused to people with cognitive problems, is very interesting. Do you think that this research will move on that way? Yeah, could be. Well, Victor, thank you very much. If you haven't got any more questions, we'll move on to the next speaker. And if you have any kind of doubt in the end, we'll have time to do the questions. Our next speaker is Marta Pérez Seco, therapeutic, who will talk about something that is related to this concept, which is virtual reality applied in
Well, thank you very much. Let's see. From the Spinal Cord Injury Foundation, we've started working with the console as a means of, as a tool, a supplementary tool for rehabilitation.
¿Cómo lo hacemos?
Sí, lo van a...
Ah, vale. Bueno, la persona con
And the person, anyone with chronic spinal cord injury has, of course, reduced mobility and sensitivity, and goes through a rehabilitation process that could take all of one's lifetime. This means that treatment can become very monotonous and motivation can fall. So from the occupational therapy department, we have created a program using the console and its games. For those of you who are unfamiliar with the Wii console, it's a console that has three-dimensional movements through device and sensors. It's got feedback that is visual and auditive, and you can see that things are done well, and you can also hear noises, like if you hit a ball with a racket, you hear that. It's easy to use, it's intuitive, it's low cost. It's not something you would purchase every day, but it's certainly something within the possibilities of persons who want to buy it. So it's also got a wide range of games, so you can develop different skills and work with different skills. It's not something that needs a lot of space to be used, and it allows the possibility of a therapist also interacting without really interfering. We are not the first to use the Wii in rehab. There are others, and there are studies. And Laver has affirmed that there is potential benefit in the use of the Wii for physical and rehabilitation and physical therapy, and it also is a motivating tool. It promotes healthy lifestyle, and it helps with balance, coordination, lung capacity, and for persons even with severe disabilities, we've seen that you can improve alignment of one's head using the Wii. So how have we implemented this program in occupational therapy? Oh, we can't see it on the screen. We've been working for 1 year with 64 patients with spinal cord injuries. 47 of these persons were tetraplegics, and so their lower and upper body was affected, and there were many other complications, and 17 persons were paraplegics. We've also worked in 30-minute sessions once a week, both with individuals, with couples, and with groups. So does this mean that with everyone we use the Wii? No, we've had certain criteria that we've followed. And first off, we make an assessment of the dependence or independence, and look at the person's physical condition. Then we've also considered counter factors that even though there's no risk really involved with the use of the Wii, we've considered factors that could be one's low tolerance for frustration, or any heart problems, or tendinitis, or the risk of falls because of cognitive or behavioral problems. And based on all of this, we've established objectives, common objectives for persons with spinal cord injuries. cardiorespiratory affectation, low tolerance of frustration, etc. And this doesn't mean that in each game we work on all the things listed on the screen. Here we see the screen. In this table, we see different games listed and skills that can be developed using these games. On the web board, depending on the position of the patient and the level of difficulty we choose, the interaction of the therapist, for example, you might work on postures, or you might work instead on movements. We're not always going to work everything with each game. The main games that we have used have been Wii Sports and Wii Sports Resort, which consist in simulating sports. You have different levels of difficulty, and you have points, or you can directly choose your level of difficulty, and the person moves as the action is executed. When you hit the racket in the screen, you can see how it, using the remote control, you can see how the racket really hits the ball on the screen. So it's not boring, it's fun, and there's a lot of different sports that one can play using the Wii. Here's an example of some patients training, playing. They're using their shoulders to strengthen their shoulders through a tennis game. And then we have Zumba and Just Dance games. In this case, it's all about imitating what you see on the screen. We do choreographies. And mobility and strength is something we work on. You don't see whether the doll doesn't work like you move. You have to move like the doll moves. But there's also a score at the end of the game, and you can see the how you've done. This is an example of a group session where several users were dancing. Here we have a table of movements made using the most often used games in the department. And depending on how we've adapted this game and how we want to work, we will choose to work on one movement or another. We're not going to work on all movements with all games. It depends on the patient that we will make a selection to work on certain things. Moving along, I have to say we have the Wii Remote device, which is one that has characteristics that are adapted to persons with upper body disabilities. You don't have to be able to grasp it with your fingers. You can just hold it in your palm. The buttons are not necessary. It has a sticky cover, and it's got its own stimulus. Furthermore, there's the possibility of creating an avatar game for each user adapted to the person's physical characteristics. And this it requires more involvement when you're making movements, because it's your person, it's you with your name who's the player and has records. So that's more stimulating for the individual and more exciting than if you're just anonymous or a doll that everyone uses. And in terms of how we go about our work method and assessment and objectives, what we can do for treatment Using the we can determine the position in which the patient encounters him or herself and the difficulty and the duration of the game. We can also work on different positions. Here in Sala station, we could work on motor control of the upper members of the body, or we could put ourselves in a more demanding situation where we have a tetraplegic, for example, and on a mattress, and a lot of balance is required there. Or we could sit the person on a ball. And on standing position, we have other exercises and movements that we can work on. On the right, you see that there was some preceding work to align the ankle and put it in the right position. Then afterwards, while we're controlling that position, the patient plays. So it's a lot easier to integrate the right posture within the person's without interfering. And in terms of adaptations, it's also true that even though the Wii is accessible, it's not something that works for everybody. So we've made some adaptations in the department. Depending on user needs, we have a steering wheel, which is an accessory for Wii. We haven't used it for that, but we've used it for persons who have no ability to grasp. By placing their hand on the steering wheel, even though it's not a driving game, they can use it, and it helps us work with them in moving their hand. And it's also good to move electric wheelchairs. We also have gloves and bandages for persons who can grasp the device but don't have enough strength to hold it for long. And with these cinches, they can. And also in persons who can only move their neck, we've placed helmets with remote controls on top, and they've been able to use it. And in the case that it's necessary to use to press on buttons, you can use tape. Here are our results that we've attained. In our experiment, we found that we had greater motivation in activities, and the games were more entertaining, and we could even have championships. We had greater adherence to treatment, and because when you get points, it's something that reinforces the individual, and the individual realizes that he or she is making progress and learning, so it makes it more exciting. And there's immediate feedback. That's something else that's very important, and the therapist is involved, but it's easier to integrate movement and attain the goals that we mentioned earlier. And the advantage of this device is that since it's accessible and we have made some adaptations to it, it offers a new way of experimenting and with leisure. And also it's something that is a way to get exercise. The bad thing about it is that since it's not a console that is really meant for rehabilitation, there are some things that we'd like to see improved in this device. You cannot register data in a detailed way. You can't always adapt it to difficulties that our patients have. We would also like to be able to use just maybe one joint, work on one joint and not all joints of the body. And the use of buttons is something that always limits activities to some degree. But it's true that, and in accordance with the previous studies, it improves daily activities and it improves motivation incredibly. It also promotes physical activity. And as a conclusion, we can say that the features and adaptations that we've found have provided accessible technology. The game is set forth in such a way, and the advantages that arise are make people want to play the game. They're eager, and then as a tool, the value makes it a good tool for rehabilitation. In occupational therapy, it's very motivating. This tool is very motivating. And in any case, we would like to continue studying the data that we've obtained and continue making experiments with other consoles. Right now, we're working with Connect. So I urge you to also do your own research and let everyone play. Thank you. Well, Marta, thank you very much. You can stay up here if you'd like. We're going to have a few questions now. Does anyone have a question about some game of the Wii? No questions? Yes? There's a microphone you can use, otherwise we can't record.
Gracias.
Thank you. You mentioned Connect. Why did you decide to use the Wii console first instead of Connect? Connect has a camera that recognizes all movements and doesn't need a remote control. Well, it's not that we decided first to use one before the other. First, we had a Wii, and recently we've acquired Connect. But Connect, it's true that even though it recognizes the joints and hands, persons in wheelchairs, it doesn't recognize them well. There are many games which require both the use of hands as well as the lower limbs. So anyone who is seated, it won't be able for anyone seated to play the Connect game, so I think it's less accessible, actually. Any other question? I have one. Do you think that in the market we'll see specific games for persons who need this type of training or rehabilitation? We're trying to make that a reality. It's a project that we have, and I think that we have created a game for Wii. I don't know if you're familiar with it. It's called Bosha. It's for the Paralympics. And why didn't it, why hasn't it been used more? Well, I think it was more a project than something to really be commercialized, but it's been made, and we have our expectations, and projects are headed in the same direction, whether we're Paralympics or rehabilitation. Well, thank you, Marta. And now we'll go on to the third speaker of this workshop, Eloy. Eloy Urendes is from the group bioengineering of the Higher Council of Scientific Research in Spain, and he's going to talk about support and stabilization in walking, in rehab processes. Good afternoon. First off, I'd like to thank the ONCE Foundation and the Ethical Technical Committee for allowing me to be here today. And in second place, I'd like to thank the National Institute of Physical Education and the Hospital for Paraplegics, who have made it possible for me to be involved in this evaluation and study. This is within a project. It's entitled Behavior. Well, human mobility is one of the main human capabilities, and it affects many different things. Our ability to walk, our personal tasks that we can undertake, our social and professional relationships, our physiological and psychological matters. So rehabilitation we're trying to recoup that mobility, and I have different aids for this. First of all, we would have simple support devices such as crutches or canes, and then the parallel bars and the walkers. These try to stabilize the patient and gives security to the patient and support upper members. And walkers, there are two types. There's simple and instrumented walkers. The simple ones are what we use most often, and then the instrumented walkers are those that are still under research, and they help the user, depending on his needs, to keep the most to move as naturally as possible. There is one that's called Symbiosis, which has been developed with two peculiarities. It allows partial load of weight, and this is very important for many people, and it has an electronic system incorporated in that, and an ultrasound system, which allows the user to identify intentions of movement. So when the user is a person who is going to make a movement, the walker supports him and goes ahead, follows him. Then we have cranes and arches that suspend the patient or part of his body, and basically, given usually the weight of the person, you can see that there are some that allow them to move from one place to another, and then there are some that are just go along move from the ceiling in one direction. Then we have walkers that are more sophisticated, and these are on a rolling platform. It has a skeleton, and then passive ankles that move at a certain speed as the user designates. And their games can be incorporated, and we get feedback and stimulation. And then we have the walker on the left, the HAP walker. This is trying to suspend weight and has independent platforms which try to conform adaptable terrain. And you can put more or less resistance, and this can be used to change up the exercises for the patient. Then we have movement on the floor using the pelvis, and the main thing here is stability, personal stability. We have a person here helping the patient undertake exercises, and there's a trainer. Here we have on the right something that allows the person to move across the floor, and this is something that the user finds very pleasing, because from having been in a wheelchair, being able to be upright and moving, and not just on a band. This is actually a type of vehicle that can go anywhere. Then we have Removi, which is an exoskeleton in a suspended platform.
The target population are people with medullary diseases. Regarding the subjects, as I was commenting, it's a bilateral orthosis that acts on knee, ankle, and hip, and we are acting on a cyclical way regarding some patterns. About the suspension platform that we call Removi, it's a suspension system that supports the ground through a user and enables the movement on that floor. The movement of the wheelchair on an automated way is possible, and it's every time possible to control the discharge level of the user. How have we accomplished that? There has been a mechanical design formed by two articulated arms on a column, as you can see in the figure, that is activated by a direct current engine. The configuration has driving wheels, which are activated by DC motors, and free rear wheels. Just a second. Well, about the mechanical part. Regarding the electronic part, as we can see, we would have sensors in the hooking point, which indicate as the force that is being suspended, three-dimensional force, an angular sensor that will enable us to know in which angle are the elevation bars, an ultrasound sensor that will enable us to detect at which distance is between the user and the Removi device, and this ultrasound sensor is in the column, and this distance will be critical to integrate the exoskeleton. Specifically in the point in which we are, the integration of this exoskeleton, you can see it through this drawing. We are looking for the integration of the subject with the Removi system. We are developing the suspension force and a distance to know which distance is the user from the platform, because if he or she is very far away or very close, that would be a critical situation, and we have to need to have a comfortable distance. That's the first point, and the second point is that the exoskeleton has a walking pattern, so that the user activates the exoskeleton, starts walking, and in every moment the Removi system has to follow him or her, keeping that security distance. Now we will watch a video where we can see how this transference process is made. Well, this is me, and first of all I can hook everything. I can hook myself to the articulated arms. If we couldn't, we would have the competent people, and this is the transference process on an automated way. Now I'm suspended, and now I'm absolutely hanged, as you can see in the figure. And in this position, what we will do is to impose the exoskeleton. We would put the exoskeleton, we dress it, and then the responsibles would activate this exoskeleton. it's proven that the 30% is the most recommended percentage. Otherwise we could see some atypical situations, etc. To validate the system, and as I was commenting before, the two critical parameters are the suspension forces and the identification of that distance between the user and the system. In order to study how these parameters change, we have assessed it at different speeds. We are talking about 0.1, 0.2, and 0.3 meters per second, and enables the user to hold or not to hold to the system. Here we can see the vectors of the forces, suspension forces. And the two exercises made is, first of all, the remover structure establishes a fixed speed, and the user has to follow the system. And secondly, the user pushes the remover system with the free driving wheels to see which is the most comfortable possibility. The conditions, and I've told you, is a suspension of the user at the 30%. There is not a weight adjustment. Once we have started the exercise, that weight is fixed, and this test has been made to a user of 90 kilogram. As I didn't have any video, I've acted for this. Well, I'm following the speed to see if I'm comfortable or if I have space enough to move myself on a natural way. These force signal is obtained directly from sensors, and we can see the 30% of discharge with fluctuations around the average. These fluctuations are repeating. Well, it's some kind of M, are cyclical, that are because of the moving pattern. Secondly, we have seen that the convergence in force and weight is constant regardless of the holding. This suspension force is always constant, so we are talking about an average of about 30%. About the advance force and the side force have been constant regardless of the exercise, and the separation distance between the user and removee, we can see that 23 centimeters is an optimal distance to develop this process. The second exercise, we've seen that there's a change in the suspension force because as the user had to push the system, but this discharge is not significant, and it still exists around the average. And about the separation distance, it has increased, and that means that on a free situation, the user marks the pattern. He increases a little bit the separation distance, and this distance keeps constant. This distance will be taken into account to make a control of closed loop between the user and the remover system to guarantee that that area is enough so that the user can walk. The conclusions, first of all, the weight converges at the level that has been selected. The suspension system works correctly. There are no modifications in the side and advanced components. There are some cyclical fluctuations on the weight. We should see the differences within for example, to walk on these oscillations. And secondly, about the distance, we've seen that there's a correct distance of separation distance between the removee system and the person. And we will use this distance in the integration as an entry signal to control both devices. And well, thank you very much for your attention. If anybody has any kind of doubt, thank you.
¿Alguna pregunta específica?
Is there any question?
It's his fault.
I would like to know which is your opinion about the medium to long term of these developments. Which are the barriers? Which are the opportunities? Well, specifically, we are making developments focused on focused on system with high level of freedom. First of all, we had Locomat. In this case, the ankle was passive. Now the ankle is controlled, and we are on that research of trying to repeat a cyclical process. Well, but the problem is that we have to include sensorial information so that we can use electrostimulation systems to have a complete system. In the future, we expect to have an integrated system that can enable us to keep this path. Well, yeah, there's one question. Can we have a microphone, please? Yeah, I wanted to ask you about the exoskeleton. If you think about not only is the exoskeleton the one that moves, but the person, for example, can move one leg and not the other. If you can combine both options, I mean, one leg to be moved passively, but the other one can be used for walking, or at least for its part of force. Yeah, if he or she has one functional leg, we can use prosthesis, bilateral prosthesis, and you see the hip or the ankle has to be until this angle. I have the ankle until this, up to this angle. If I have a functional leg, we can dress just one leg. He should go with some kind of help because of stability reasons, and if he has both legs with some capability of movement, we could use some other control strategies, for example, the force control. And these strategies are being implemented, so it detects the amount of force that you can exercise. You can move up to that degree, and the rest that you need is provided by the exoskeleton. The third would be with integration, with functional integration. Now, the phase lets you let yourself and you act, and then the controls would help you. If there are no questions, well, I'd like to thank Victor and Marta and Eloy. Thank you for your attendance, and to the Fundación 11 for giving us the chance to be here and to take the floor in this event. And regarding in the program, tomorrow at 8:39 we have the new registration, and from 9 o'clock on we have demonstrations meeting. Thank you very much.